Welcome to IOS451. We are going to continue with our series of classes where we look at binding Objective-C libraries so that we can use them in our Xamarin iOS applications. So today's class is building an Objective-C bindings library with Sharpie. One thing I do need to note up front is that you need access to a Mac, so please make sure that you have a Mac machine available with the latest version of Xcode installed and at least Mac OS 10.10. This is a hard requirement which we'll talk about again a little bit later, so let's jump into the material and see how to use Sharpie. Before we jump into this course's content, let's quickly recap the process of binding an Objective-C library. Your first step is to find the umbrella header file and determine which headers to bind. If no umbrella header file exists, you'll have to figure out which headers to bind manually. You will then, for each constant, enum, struct, class, and protocol in each header file, create a corresponding CS class file and manually create a corresponding C# constant, enum, struct, and class, as well as protocol implementation. Where applicable, make sure you have the correct type registration, and for each of these, export the correct constructor and required member definitions. Last but not least, for protocols, make sure you create the correct interface and/or abstract class implementations and that you take into consideration optional and required methods. And as you can imagine, this is one class, so we'll then rinse and repeat. So this process is rather tedious, as you by now most likely have recognized. There must be an easier way to achieve the same, and this is what this class is all about. We're going to look at how to speed up the process by introducing Sharpie. This means that by the end of this class, you will know how to use Sharpie to create your API definition files. You'll know how to consume these created API definition files, as well as reviewing and cleaning up these files to create your binding for use in your Xamarin iOS-based projects. Let us start by looking at downloading and evaluating Sharpie. Now, to evaluate Sharpie, there's two very important questions to answer. What does Sharpie do? And what files do Sharpie really create? Because once you understand these two items, you'll have a much better experience binding your libraries. To answer these questions, we need to understand Sharpie. There are a few items I would like you to keep in mind when using Sharpie. Sharpie is a command line tool, created and maintained by the Xamarin iOS team. Sharpie allows us to bootstrap the manual coding steps that we have described so far. It also is capable of parsing header files to map the defined APIs into an editable binding definition. So this means that Sharpie knows how to interpret most of the Objective-C code constructs, and you will find it invaluable in terms of your binding workflow. Sharpie is the default binding tool within Microsoft, used to create bindings and is used for building our own products. A word of warning though, Sharpie is an advanced tool that requires advanced knowledge of Objective-C and C, how to use the Clang compiler on the command line, and generally how native libraries are put together. At this point, I'm pretty sure someone is thinking, hang on, hold on. I thought Sharpie creates C# code that I'm able to compile into a Xamarin iOS-based DLL. What is this binding definition that you're talking about? The binding definition is a contract containing the namespace and interface definitions used to generate your final API. Since Sharpie interprets most of the Objective-C code, you should think of this binding definition as an intermediate step, which allows you the opportunity to clean up and extend your C# API as may be needed. And in doing so, also save you a lot of time. However, I do not blame you if you initially look at the API definition files and think, oh, this is C# code, which is directly going to result in a binary outcome. We need to explore these files a little bit further before we actually get to the point where we have C# code that is compilable into a binary. Sharpie will generate an API definition file, and then potentially it will generate a second file, which is a structs and enums file. This is really dependent on the actual API that you're binding to. In case you plan to distribute your binding library or make it available to other developers in your team, it is also generally seen as good practice to create an extra CS class file, which might expand the generated binding or just provide a more C# friendly API to use. This is, however, completely optional. To get to a compiled library, the library you are binding to also needs to be added to the project. So this is your static library. At compile time, the core binding files are now going to be generated. Right, so these will be the files that actually result in a binary. It's from here that your binding DLL is generated, which you'll then be able to reference in your project. So at this point, we have a high level view of what is going to happen. I want us to now jump into the actual use cases available to us and see how to use Objective-Sharpie in those. The first step in using Objective-Sharpie is to download the install package. Please take note, Objective-Sharpie is a standalone component, and at this stage it is not a fully supported customer-facing product. You also need to be aware of the following prerequisites. You need to run Mac OS 10.10 or above. You need the latest stable version of Xcode. You need to install the Xcode command line tools. And also remember to make sure that you have downloaded the Apple SDKs you would like to bind your API against. This process is managed via Xcode by installing all the versions of the iOS SDKs and simulators as needed. For the rest of this class, I'm going to assume you have these prerequisites installed, that everything is in place to carry on. Now that we have a high-level understanding of what makes a binding definition as well as the prerequisites to run Objective-Sharpie, let's give it a go. It might be that you already have Objective-Sharpie installed on your machine. If not, however, I would like you to visit the download link provided in the start here HTML file to go and fetch Objective-Sharpie and install it. Once that's in place, you should be able to run Sharpie-help, which will allow you to verify that Objective-Sharpie is actually executing, and it should give us an output matching the following. This is the usage instructions for Objective-Sharpie, and we'll make use of the available tools to bind our libraries as next steps. The usage output of the help command is very useful in terms of managing bindings and indicative of the type of projects that you are able to parse using Objective-Sharpie. There are three main items I would like to highlight. The first is Xcode. So this option provides information about the current Xcode installation and the versions of iOS and Mac OS SDKs that are available on your machine. You will use this information later when generating bindings. The second option is the pod or CocoaPods option. This option searches for, configures and installs and binds Objective-C CocoaPod libraries available from the master spec repository. This tool evaluates the installed CocoaPod to automatically work out the correct input to pass to the bind tool, which we'll talk about a little bit later. And the binding CocoaPods process does have a dependency though. You have to have Ruby installed, which you should be aware of. The last option that we are going to look at is bind. This option is a tool that parses the header files, and it's going to then generate the initial API definition and struct and enum files as required. Those files that is the initial set of our binding definition. We are going to look at each of these in turn in our next objective. It is always a good idea to inspect the Xcode SDK versions installed in your machine. When you run Sharpie Xcode-SDKs, an output listing will be displayed listing all installed SDKs. Remember though, the SDKs are managed via Xcode. Should you wish to install or remove SDKs, you will have to use it. Some libraries may have a dependency against specific versions of SDKs, which makes this step rather important. It is important also to note that an SDK version must always be part of the parameter set passed to the binding command. We'll make sure to highlight that as we go through our examples. Demonstration time. Let's download Objective-Sharpie and check the installation. To download Objective-Sharpie, head over to docs.microsoft.com and search for creating bindings with Objective-Sharpie. Once you're on this page, scroll down to the section just below History, which reads Objective-Sharpie Download. Click on the link and wait for the download to complete. Once your download is complete, select the item and run it. This is going to step you through a wizard which will allow you to install Objective-Sharpie. Make your selection, click Continue and complete the installation. I'll wait for you while you do that. Once you have Objective-Sharpie installed, the next step would be to open up a terminal window and just type in Sharpie. Now, Objective-Sharpie is an EXE, right? So it's a C# compiled project. This has a hard dependency on mono, as you can imagine. If this command fails, so if you type in Sharpie without any parameters and execute it, and do not receive this output, it means that either mono is faulty or the binary is at fault. Generally speaking though, we're going to assume that mono is installed and everything is set up as proper. If Sharpie fails, however, you are going to have to re-download the binary, or you will have to look for a new version of the tooling. Either way, I would suggest reaching out on the forums, telling us what the problem is, and someone will assist you. In this objective, we are going to look at how API definitions are created using Objective-Sharpie. To start with, we want to cover using Objective-Sharpie with an Xcode project. We'll then move on to a CocoaPods project, and then last but not least, we'll look at a project where we need to specify specific parameters so that we can create a functional binding definition. Objective-Sharpie supports 3 project styles to create bindings from. The first is parsing an Xcode project to select the correct header files and compiler flags. The Xcode project will be compiled and the API definition files created from here. The second option is using CocoaPods. CocoaPods is the dependency manager for Objective-C or Swift projects. Project dependencies are linked together in an Xcode workspace from where Objective-Sharpie will then follow the same process as with an Xcode project, which means compile the project and create the API definition files. The last option is a manual approach. This approach potentially uses Xcode build to build your Xcode project, and then you manually determine the Objective-Sharpie input. Normally the command line parameter configuration will require specific input from you, and it's generally not as simple as the previous 2 options that we have available to us. Let us look at the Xcode project option first. There are generally 3 steps required if you are going to bind an Xcode project. The first step is to clone your project from its relevant source repository. Then, using the command line, you will point Objective-Sharpie to the Xcode project file. The last step is to make sure you specify the SDK version you wish to bind against. Important, this SDK must be installed on your machine. Assume you want to bind the Facebook Pop library. The Facebook Pop library is an extensible animation engine for iOS, tvOS, and OS X, and makes a good binding candidate. As your first step, you will fetch the Xcode project from the Facebook GitHub repository. And remember, when cloning any Git repository, a subfolder will be created with your source code inside it. So please remember to change to this folder before you execute any additional commands. Next, you will execute the Objective-Sharpie binding command. An important note to make here is that the Xcode project must include one or multiple build configurations set up. Without these, Objective-Sharpie cannot inspect the project and therefore cannot complete the binding. It is also important to specify the iOS SDK version that you are going to bind against. If this SDK version is not installed on your machine, make sure to install it using Xcode. Right, we have now all the bits. Let's see what an example of this looks like. Your first step will be to download the Facebook Pop library using the git command. This means we are going to jump into a terminal, fetch this repository, and then we'll switch and use Objective-Sharpie to bind this library using the Xcode project option. Our first step in the console is to clone the GitHub repo. We'll use the git clone command to fetch the repository from GitHub. We'll make sure to use the correct URL. So that should be github.com Facebook pop.git. Once the repository is cloned, we'll make sure to change into it and do a quick directory listing. What I'm looking for is the actual Xcode project that we are going to target. Now, before we target this Xcode project, there's actually one more thing we need to do. We need to make sure that we also know which SDKs are installed on this machine that you're going to use. Now, to do this, we'll execute the Sharpie command, specify Xcode, and then -SDKs. That should return something like this. Now, on this machine, you'll notice that I have the iPhone OS 11.4 SDK installed. My next command is going to be Sharpie bind. Now, binding in this sense is a little bit of a misnomer. What Sharpie will do, as I've explained earlier, is create API definition files. At this point, we'll have definition files so that we can create a binding, which means there will be additional work that needs to happen. Let's complete this and see what it looks like. As I've mentioned earlier on, we're going to target that pop Xcode project. So let's make sure that we have that selected. And then we have to specify the SDK that's installed. In this case, iPhone OS 11.4. Now, as soon as I execute this, the Xcode build process will build this project. It'll create the static library that we'll be able to bind to, parse the headers, and create the API definition files. Once this is complete, we'll be able to use those files in an iOS binding project. However, there's one or two things that might be interesting at this point. You may have noticed that there's a warning. And this warning, one has to keep in mind going forward. It might be a problem, but it might not. The most important thing here to take away from at this point is that you will need to understand your API definition and the implementation thereof to make sure that something like this is not potentially a problem. We'll assume it's not, but if it is, then you are going to look at the other options to bind a library, either using CocoaPods or, last resort, move on to a manual binding process. In terms of the API definitions, you'll see that we have an API definition plus a struct and enum that is supposedly written. We'll be able to double check it and make sure that's the case. If you look at the rest of the output, you'll see there's a binding analysis done, and this is going to indicate how much additional verification we will need to do inside these definition files. At this point, it doesn't seem too bad, but it's definitely something we will need to look at as well. The last step is to see if we can find those definition files. Now, what you'll notice if I do another directory listing is that we have the API definition CS file right here, as well as the structs and enum CS files. You may say, but Chris, that's a little bit annoying. Why are these files directly in this folder? There's one more option that we can add to our binding project to clean this up. We are able to specify an output folder. So I will be able to do something like this. Output, bindings. And now those two files should end up inside the bindings folder. Notice though that the compilation will happen again. Everything else will get parsed, and what we'll find now is that we have a bindings folder. So we'll be able to change into that folder. You'll see your API files are in here. Right, so these are the options available to you. Let's go back to our slides and see the same process using CocoaPods, then finally using the manual approach. The second project type to investigate is the option to bind a CocoaPods project. We are not going to cover the setup of the CocoaPod support on a machine. However, there are a couple of things I would like to mention. CocoaPods is a dependency manager for Swift and Objective-C Cocoa projects. An analogy here would be to think of the NuGet package manager we use in our .NET world. The CocoaPod infrastructure is built with Ruby and distributed as a Ruby gem. Ruby on its turn is installed with the default OS X Ruby installation. However, it will be time well spent investigating the installation instructions at cocoaspod.org. As part of an Xcode project, CocoaPods makes it easy to manage dependencies. Objective Sharpie supports binding CocoaPods and allows for downloading, configuring, and building these CocoaPods. Again, make sure to investigate the installation instructions over at cocoapods.org. There are two steps involved when using CocoaPods with Objective Sharpie. The first step is to initialize the CocoaPods binding project. This step will most often download and set up the pod which contains the related Xcode project and workspace, as well as download, install, or update all required dependencies. The second step is to create the binding using the relevant Objective Sharpie binding command. The first step in binding a CocoaPod is to initialize the pod project. This process will download the pod and set up the Xcode project and workspace. Here's an example of initializing the AF Network CocoaPod. We're going to make use of the command Sharpie pod init iOS to specify that you are going to use an iOS project, and then the name of the actual pod. Notice how the last version of the CocoaPod is fetched, as well as all additional dependencies that may reside here. One thing to watch out for is that the command will initialize the project in the current folder where you are executing it. make sure to create your working directory first and then change to it before executing the command. The initialization process may take some time to complete. However, once completed, you are able to run the Objective Sharpie binding command. This will produce the binding definition files to use later. Now, here's the continuation of this process. We're going to run Sharpie pod bind, and this, after a couple of minutes, potentially, will produce your API definition CS and structs and enum CS files. These we'll use in our project to finalize the binding process. Another option in terms of generating bindings is to make use of Sharpie's capabilities of being able to parse a CocoaPod implementation. So in this demo, we're going to initialize a CocoaPod project for AF networking and see how to use Sharpie to actually bind the final API definition files for us. Let's jump back into our dark space, into the terminal. And once you're here, the first step that you will probably want to do is create a folder. We're not going to clone the project directly. We're going to rely on Sharpie to do so. So what I'm going to do is make a directory first. I'll call it AF networking. That's what we would like to pull down. Then I'll change into that directory. Once you're inside this directory or folder, you are going to initialize the binding. So the way we do this is to specify pod, call in init, and this is going to make sure that we have the latest and greatest for CocoaPods in terms of that project, and then at least the support in Ruby, and then we're going to see that the AF networking project will be set up. So the CocoaPod will be fetched, everything gets properly placed. Once that's done, we'll call Sharpie pod bind, which is going to compile the project and generate the definition files for us. But what's interesting here is that you'll notice that I'm not going to, when I do the next command line execution, I'm not going to specify an output folder like we did in the initial project. Right, so let's get this going. This is going to pull down and check that I've got the latest and greatest CocoaPods support in my Ruby installation. Once that is done, this does take a couple of seconds. The actual repo will be fetched for the AF networking project. Once that's done and set up, we'll get command control back, and then we'll initialize the binding. So we have to wait for this to complete. It'll take a couple of seconds. Should anything fail at this point, you will have to revisit your Ruby installation plus your gem configuration. Any fix is beyond the scope of this class. My suggestion is that you visit the online forums and post your questions there. We'll gladly help out with any assistance that we can give. Right, so at this point, the pod file has been downloaded, basically that CocoaPods project, and our next step is to call Sharpie pod bind. Now, you'll notice here, like I alluded a little bit earlier to, I'm not going to specify an output folder, and I'll show you as soon as the compilation completes why I don't do this. So the command that we're going to run at this point is Sharpie pod bind. The framework actually now gets generated. So we need access to the framework implementation that this CocoaPod is going to provide us with. And that's one of the reasons why this command actually goes and sets up an output folder for us. So you'll see again, there's a couple of items that needs cleaning up in this project. We won't discuss that right now, but we would be able to go and have a look at the binding. So CocoaPod bind is going to create a binding folder. If you change your directory to that, have a look at the contents, you'll see the AF networking framework. That's now available to us. Inside that, it's actually a folder, but inside it you'll find your header files, you'll find your actual static library that you will be able to actually bind to at the end of the day. And we'll see how to consume these guys as well later in this class. For now, notice we have an API definition, which means we can have a quick look at that for interest sake. AF networking API definition, you can see the same familiar kind of code that we saw earlier on. Okay, so that's what we have when we use Sharpie to bind CocoaPods. Let's jump back into our slides. There will be scenarios where you will be required to modify either header files or provide additional parameters to Objective Sharpie so as to create the binding definition files that you will need. It's in these instances where we are going to look at manually binding our libraries. The first step is, however, optional. But most often than not, you will need to source the source code for the original Xcode project so that you can compile it and potentially create FAT files, for example. The second step, however, is dependent on step one. So if it's not needed, then both of them aren't required. The third step, generally speaking, is the reason for choosing a manual binding option. You will need to either inspect the library documentation or alternatively the project code to determine the changes that are required. It may be that you need to create an umbrella header file for yourself, or you have to exclude specific files not needed inside the definition. The last step is to pass the project-specific parameters to Objective-Sharpie or the underlying tooling which Objective-Sharpie uses. We'll look into this process in much more detail going forward. Some libraries require you to have more fine-grained control over the compilation of the required library, as well as picking the specific headers defining the API. The first step is to source the library. This may be an already compiled library or an Xcode project that you still need to compile. In this example, we're going to look at the steps to bind the same Facebook Pop library that we spoke about earlier on today. As mentioned before, Pop is an extensible animation engine for iOS, tvOS, and OS X. And in this first step, we'll fetch the Xcode project from the Facebook GitHub repository. And once done, we're going to make sure that we change into that folder that was created. When building your Xcode projects, you will make use of Xcode Build. Xcode Build is a command line tool that is provided as part of the Xcode distribution. Notice that we are going to pass or specify two specific parameters here. The first parameter is the SDK version that you're going to target, in this case iPhone OS 11. The second parameter is the actual binary type that you would like to target. So for instance, here we target a device. If you were going to target a simulator, you would specify that as x86_64. This step is therefore the opportune moment for you in your manual binding process to create a FAT file where you can combine multiple architectures. Your next step is to locate the header files for this library. Again, assuming the Facebook library, you will find the header files located in the relative build headers pop folder. A file listing should return a result similar to what you see here. We are interested in the pop.h file. Now, generally speaking, when you make use of frameworks, your umbrella header files will match the name of the framework file itself. This is, however, not always the case. And for that reason, you will have to go and search for this. But that's a rule of thumb to keep in mind. If this file does not exist, then you will have to create one yourself. Or you will have to modify the contents of this file in some instances. But before we get to that step, let's have a look at what our command line will look like after we've highlighted which file we would like to use. When binding a project manually with Objective-Sharpie, you will need to provide project-specific parameters. These parameters include standard options, for example, structuring of folders containing the project output or passing special instructions to Clang, the compiler frontend used to compile Objective-C and various other languages. We are going to step through each of these parameters, so let's start with the very first one, which is output. Output allows you to specify the folder in which your API definition CS and structs and enums files will be found. The next parameter is the C# namespace that will be used for your binding. This is the namespace that will be included in all code consuming the API via C# using statement. Specifying the SDK version to use in your binding is a very important aspect and must not be left out. For example, if your binding requires iPhone iOS 11 or iOS 11, then you'll have to specify this. The important aspect to remember, though, is that SDKs are managed via Xcode, and you will have to download additional SDKs as required using that tooling. You'll notice that we pass a -scope argument to Objective-Sharpie. Because C and Objective-C libraries must import or include other header files that are implementation details of a specific API, which means these are libraries that aren't specific to what you want to bind. We want to generally exclude these from being bound as well. Unless we do this, we'll end up with very large API definition files. So we are able to specify to Objective-Sharpie to ignore these APIs, which means that anything that does not reside in the -scope directory specified will be ignored. You will find that the -scope argument is often optional for clearly implemented libraries. However, there is no harm in explicitly providing or specifying it. Remember to specify your header file. This file either will pre-exist and you have modified it, or you will have to create one yourself. But make sure that you do specify this file, otherwise your binding will fail. Objective-Sharpie uses the Clang compiler underneath the hood. You are able to guide the behavior of Clang using the -c argument. This argument allows you to indicate that all subsequent parameters will be passed to Clang, in this instance the location of the library files. Should you require more information about Clang, I would highly recommend you to visit the llvm.org website, which covers the Clang implementation. The last option is to specify the architecture for your specific library. With these arguments in place, we're now ready to press the enter button, and hopefully Sharpie will be able to bind your API. Let's have a look at the results. On a successful run, Objective-Sharpie will generate an API definition CS file and potentially a struct and enums CS file. Now, you may find that your API only generates one API definitions file and no structs and enums file. Don't be surprised when this happens. It's not an error. Some APIs do not define structs and enums, and therefore nothing can be generated. In our next demonstration, we'll have a look at what happens when Sharpie fails. I'm going to deliberately omit parameters past Objective-Sharpie. Alternatively, I'm going to mistype one or two parameters, and we'll see what the effects thereof will have on our final outcome. I am going to follow the steps as per our next exercise, so you'll have a good idea in terms of what needs to happen when you get the chance to run that exercise yourself. Our first step here is to go and fetch our GitHub repo. I'm going to assume you haven't fetched the library. If you've done so, you're welcome to change to a different folder, but generally speaking, this is going to be what will happen. We'll go and clone the GitHub repo. So you're going to make sure that you have the proper address in place. So https://github.com, Facebook. Then once we have Facebook in place, we should be able to go and say, well, okay, the repo's name is pop.git. Execute this. The repo should be cloned, and then we'll change directory into the pop folder. Now, at this point, we need to make sure that we actually build the Facebook library. So here we're going to make use of Xcode build. Xcode build is part of the Xcode tooling installation. Make sure that you have this available. One of the parameters we need to pass in is the phone OS that we would like to target, in this case iPhone OS 11.4. And then we'll also need to specify the architecture we want to build against. Now, architecture options that are available, generally speaking, should include x86, but let's see if that's actually the case. So I'm going to specify x86-64. This may work or may not. Actually, you see it fails. So what's the problem? Well, the problem is that the only architectures supported for compilation at this point is ARM64, ARM v7, and v7s. Okay, so we won't be able to use x86. What we should be able to use is ARM64. So let's pick that, and at this point, yes, there you go. The library is being built. Now, once this is complete, there should be a build folder. So let's have a look. If I do directory listing, you can see, yeah, there you go. There's the build folder. So we would like to use that. Let's have a look at what's inside this. So if I change directory into build, in here, we'll find there's a release iPhone OS folder inside it. Let's have a look at this. There's an include, there's our libpop.a file, so that's our static library. We have to include this into our final iOS binding project, but for now, I'm looking for my umbrella header file. So if I change directory into include, we do an ls here. All right, so there's another folder. Let's do this one more time. There you go. Excellent. So here's my umbrella header file, and here's all the other files that's going to be used. Right, with this information, we have enough info to go back and start using Objective-Sharpie. So let's just go back. I want to exit all of these folders prior to build, so that if we have to read on Xcode build, we are in the proper location to do so. Right, so what does my Sharpie command look like? Well, the Sharpie command is going to include the following. Sharpie bind, to specify that we want to do a binding. I also want to specify an output folder, so as to where my bindings is going to end up. So I want to specify Xamarin Facebook API. That should be fine. And then I want to specify a namespace as well. So from a namespace point of view, I would like to specify Facebook pop. Right, that should be sufficient. And then I need to specify the SDK I'm going to bind against. So SDK iPhone OS 11.4, and this is exactly the same as when we built this library. And then what else do we need? Well, we probably need to specify which header file we would like to use. So what I'll do is I'm going to specify that we want to bind in the build folder, then the release folder, then the include folder, then the pop folder, the the actual umbrella file, pop.h. Okay, great stuff. So let's see what happens when we press enter. Okay, so we hit an error. Well, what is happening here? So there's a problem here. Sharpie tells me that it's trying to parse pop.h, but then there's a fatal error. It couldn't find pop defines.h. Now what is wrong here? To figure out what's wrong here, we actually have to go and load the pop defines.h file, or at least the pop umbrella file. So we probably end up looking at both those. Let's do this. Let's use Sublime. I like using Sublime as my text editor. I just want a text editor. I don't want an IDE. Don't want a craft of the IDE around. I just want to look at these files. So I'm going to head over and say, well, you know what? Let's go and load all the files in that include folder that's available. So let's do this. Okay, so yeah, all my files loaded. Now the file that gave me a problem was the pop umbrella file. Let's see if we can figure out what's happening inside it. I'm going to just size my screen a little bit. Let's see if we can find that file, pop.h. There you go, very first file. Okay, so this is the problem. The structure of this folder is a little bit off. The pop.h file resides in the same folder as all of these other files. So what we have to do is we have to get rid of that pop section in the front. Now what I normally do is go and find replace. I've pre-populated what I want to replace, and I want to replace this with an actual, not an angle bracket, but a quotation. So I'll show you why. I'll replace all of these. Then I need to just match up each of the ends of these, get rid of these angle brackets. So now what we say is, well, great stuff. When you parse, Sharpie, when you parse this file, have a look at it, but then go and locate each of the other files specified. They are in this same folder. They're not one sole subfolder pop. From here, they are exactly in the same folder. All right, so let's save this. Then we should be able to jump back into our terminal. Let's run this again. So what we want to do is run the same command, and let's see what happens. Okay, there seems to be an error, but we do have partial success. So let's see what that is. If we look at this output, you'll notice that we still have an issue. So there's another pop defines. Okay, so we'll probably want to clean that up, which means we'll have to look at each of the files that we have and clean them up. Then scrolling down, you can see there is an API definition CS, and there's a struct and enum CS file generated. And then a lot of verification needs to happen. We'll come back to this once we've cleaned up the files. So our next step would be to go and find pop animatable property. So that should be animatable property. That's the one. Here you now have to go and replace all of these items. And this is where this strategy becomes quite tedious. Some libraries that have been properly set up, this isn't a problem. When you can use the Xcode build option or Xcode option with Objective-Sharpie, use that, or the CocoaPods option. As you saw earlier on, it's a lot less work than this. So what this means in reality is that you'll have to jump through each of these files and find and clean up each of these items. All right, so I'm going to fast forward. It's actually quite a bit of work. I'm going to fast forward and clean these up, and then we'll speak as soon as I've done that. Once you're done with the changes to the files, please double check and make sure that you've only changed the instances where there is a pop file being included. Everything else, like NS Object Runtime, for example, or Core Graphics Foundation, should be left with angle brackets. Those implementations need to be as is. It's only going to be the files that had a pop instance header file that should change. Let us jump back into the terminal. On your terminal, we're going to rerun the command from earlier on, so the Sharpie bound command. When executing this, you'll notice though that we've now run into a different error. Remember, I've just mentioned that we shouldn't change any of the foundation includes, for example. So what is going on here? The problem is a little bit hidden in terms of what actually is going on. But there's something here that actually alludes to it, and with a bit of investigation we might find this. So let's see if we can find it. If you look at the analysis of the binding, you'll notice that there's a lot of verification that needs to be done. There's, for instance, 2,955 instances of platform invoke. Now, that seems odd to me, so let's have a look at the generated API definition. So the generated API definition is going to be in the Xamarin Facebook API folder that we have there. if we have a look at it, and actually, you know what, let's use Sublime again and open up that file. So if I go and find Xamarin API, we should get to the API definition CS file. And if we open this guy up, you'll see there's a lot of inclusions that seem to be iOS related. Look at this. This doesn't seem right. There's a lot of constants, and these things seem to point to something that I potentially don't see being part of the POP library at all. So what we need to do is we need to tell Sharpie to ignore the files that's part of the actual SDK. It's actually including them as well. So we'll need to change our command line. We'll need to pass information about the scope. So the scope here is going to make sure that we only bind or look at header files that's included in that library of ours. Ignore everything else. Only the header files that's in that POP folder. So let's see if including scope actually solves the problem. Now we're going to have to include build, the release folder, the include folder, and the POP folder. So let's run this command again. Now things start looking a little bit better. So you'll see we have 35 instances, but there's still a problem with foundation H. Maybe we didn't fix this properly. So let's go and have a look at pop animation tracer and see if we can figure out what the problem could be. Pop animation tracer, there you go. Oh, look at this. Pop animation tracer is not including or importing that file with angle brackets. We are going to have to change this. Now remember, we saw this a little bit earlier on. So we probably will want to make sure that we have the proper inclusion of foundation. So let's do that foundation. All right, I think I'm going to leave it like this. And maybe let's just do this foundation. Make sure that we have that. So saving this file, we can jump back to our command line, run the command. And that seems to be, let's see, did that fix our problem? We have missed something. Right, so this is typical to running these bindings by hand. It's quite a bit of work to make sure that everything's in place. So let's go and see, do we have to fix a pop property animation? It might be one file that we've missed. Pop property animation. Let's see. There you go. Yes, I did. Wow. Okay, so let's fix that up as well. Now, the one thing to not get is get despondent when you run these. So this is typical what you'll find when working with Objective Sharpie. I think we're starting to get there. Excellent. So we ran the command, we parsed one header file, we created an API definition, structs enum. We have a lot less of verifications to do. There's still a couple of 35 at least platform invokes, but we definitely can deal with this. If I go back to my instance of opening up the API definition file, you'll see here that this seems to be a lot better to manage. There's some delegates, there's an interface. This is what we're looking for. Okay, excellent. So we're now at the point where we're ready to include these files into an iOS binding project. So let's talk about that next. Before we continue with the next objective, I would like you to run the individual exercise that we have set up. In this exercise, we are going to bind an existing Xcode project, and you'll follow the same steps as I have done in the demonstration. In this exercise, we are going to, just like I've done in the demonstration, initiate a binding process using Objective Sharpie on an existing Xcode project. Now, the Xcode project is going to be the same pop animation that I've used. It's to have a bit of consistency. At least you will have the opportunity to go look at the demonstration and then complete the same steps. However, there's one catch here. It might be that your version of this library is different. This means that everything will be the same until you hit this section in code, where you are actually going to execute Sharpie against the library. Now, the biggest difference that you may run into is that the header files are located in a different folder, or that your umbrella header file looks different and you'll need to modify it in a different way. Generally speaking though, the concepts we've talked about will be exactly the same. So I'm going to check in with you in a couple of minutes. You run this, pause the video, and when you're done, let's continue and we'll see how to consume those API definitions that you were successfully able to create. See you soon. At this point, we have two generated API definition files, the actual API definition.cs file and the structs and enums.cs file. Both of these two files now need to be consumed in a project. And in this section, we're going to see how to do that. We have a couple of tasks that we would like to complete in this section. We'll look at describing the Xamarin iOS binding project structure, understand exactly where the API definition files reside and how they should be built. We'll then look at setting the native reference properties, so defining additional features or metadata around the binding. And then we'll move on to compiling the project and evaluating errors. There are generally 4 steps that you have to follow to consume your newly created API definition files in an iOS project. The first step is to bring the API definition files into your Visual Studio iOS binding project. This includes your API definition CS and your structs and enums CS. The second step is to add a reference to the native library that you would like to bind. Remember, this is going to have to be included as part of your API, at least your final binary that you are going to consume in your final iOS project. We are then going to compile this project. Most often though, you'll find that you are going to spend some time verifying and cleaning up any compilation errors that may follow. These 2 steps, compiling the project and verifying the files, is where you'll spend most of your time cleaning up and making sure that everything is in place so that you have a clean binary build. Our first step is to introduce the API definition structs and enum CS files that were created by Objective-Sharpie into our default project. You'll notice that the default project is created with an API definition CS plus a structs CS file. The contents of these 2 files can be one-to-one replaced by what has been created by Objective-Sharpie, and that's generally speaking what you will do. In this demonstration, we'll have a look at creating a binding project, and then we'll copy the contents of our API definitions into it. Let's see what this looks like. I'm going to create this project using Visual Studio for Mac. Staying on the Mac at this point makes a lot of sense. There's still a bit of work that needs to be done here. Now, the first step is to create a new iOS binding project. You're going to head over to the iOS configuration section in the new project wizard, select library, and then select bindings library. Click on next, and then name this project. Now, since we are using Facebook, I'll call this guy Facebook Pop, and this is going to match the namespace that I've created when I bound the library using Objective-Sharpie. I'll create this project within my projects folder, click on create, and then a template will kick in and create the basics for me. You'll notice that we have an API definition file, and there's a bit of code in here that's been commented out. However, this has no relation to what we want to build, so we're going to get rid of this file. Then we have a structs.cs file. We are also going to replace the contents of this file with what is in our Facebook Pop API definition. Here is our API definition file, plus our structs and enums file. I've opened these 2 files in a text editor, and I'm going to copy this now into the IDE. API definitions matches back to the API definition CS file that we see in the IDE, and structs and enums will end up in the structs.cs file. Copying the API definition file's contents, we'll now paste this into the IDE. Back in the IDE, we are going to drop the code here. I'm going to leave it as is. We'll come back to this file in a second. Let's go and fetch the structs and enums file's contents and get it into the structs file. We'll copy the file contents here as well, and then we'll head back again into the IDE. This is our final copy for now. Let's replace the code, and now we have our structs and enums basically back into the project. Now you may be asking me, why am I copying it? Why don't I just include the files? Delete these 2, include them, and we're set. The answer is there's 1 or 2 things we need to remember when we start adding files into a project. We need to set the specific build actions on these files. And we'll talk about that in a couple of minutes, but for now, we don't have enough information, so copy and paste seems to be sort of the easiest way out. At this point, you may figure to compile the application. So let's go and build this and see what happens. Oh my goodness, 130 errors. I'm pretty sure you guys have seen this, at least when you tried to build your own libraries. So how do we get around this? What is actually happening here? Now there's a couple of things that pop up in here. You'll see that we actually have these verify attributes. That seems to be an issue, and there's a number of these within the API definition file. I can just scroll down. You'll see on the side, on our code analysis, we are going to hit a couple of these problems. There you go. So we need to understand what happens here to fix this up. In addition to this, your structs.cs file also contains a couple of interesting informational bits. Most of these, though, will give us enough information to fix them in terms of what this error reads. So you'll see here that we expect any of these types, but not in uint. So what I should be able to do is change this into a uint. And then we'll be able to compile. And then we've solved one issue, and so on and so forth. But be aware that at this point, you do not have a compilable project. There's still some work that has to be done. If you think back to our slides, getting the content in here, verifying, rebuilding, that's the loop that we are going to hit at this point. But we need to understand what's happening here, so we'll do that next. Should you decide to remove the API definition CS and the structs CS class files and bring in the Sharpie generated files, you will have to make sure that you understand the binding build actions. So the binding project introduces 3 build actions you will use to successfully bind your library. The first option is the Objective-C binding API definition. The second is Objective-C binding core source, and the third is Objective-C binding native library. Let's have a look at each of these in turn. The API definition CS project file, and for that matter all other files which will be parsed as definition files, are always set to the Objective-C binding API definition build action. This action is used to indicate that this API definition specific file is used in a pre-compilation build step, where the file is processed to generate C# code. This C# code in turn is used to create the C# wrapper classes, which is equivalent to what we build manually in IOS450. The struct CS project file and all other files which will be compiled as C# code is set to the Opt-C binding core source build action. This build action is used to indicate that this file is used to support both the C# generation process, creating the C# wrapper classes, as well as the final compilation step to create a final binding library. So for example, we have enumerators and structs that are used to define our metadata in the API definition, but also is used in the API's consumption in your iOS application. Binaries have to be static linked in iOS. This means that your binary has to be added to the project and the build action set to Objective-C binding native library. This build action ensures the native library is therefore statically linked and part of the final binding binary. There is, however, a little bit more to this step than what meets the eye. With each library that you add to your project, a corresponding link with CS file is generated and associated to this file. This CS file is used to pass linker parameters to the underlying tooling, as well as allow you to define how the file is linked and give you an opportunity to specify additional compiler arguments. For example, your library may depend on a specific framework, or need to reference a specific library which has to be specified. Unfortunately, maintaining the link with CS file or even specifying this information is tedious and error prone. Instead of adding the library directly to the solution, you now add the library to the native references folder in the project. The link with attributes are now represented as options that can be set in the file's associated properties panel configuration. Most of these properties are GCC and Xcode related, and it'll serve you well to have a reference to the command line parameters available for both GCC and Xcode. But let's look at each of these properties and see how they are used. In some scenarios, you'll find that not all objects are loaded from your library. To override this behavior, you enable the force load option in the property panel for your native library. Force load specifies whether or not the -force load GCC argument is required when linking this native library. If any objects are missing, not loaded, you'll find missing symbol errors popping up when you try to compile your library. You'll often encounter frameworks or libraries which relies on other frameworks. For example, you might use a library which allows you to interact with a Bluetooth low energy device. In this case, your bound library might require the core Bluetooth framework as a dependency. In these scenarios, these additional frameworks need to form part of the project. You are able to specify a list of space-delimited platform frameworks that should be linked as a property. The requirement of additional frameworks, however, may not be that apparent at first. The best way to discover dependencies is to refer to the bound framework or libraries documentation, or even to inspect the sample projects in which the project is being used. The required dependencies normally will be included as part of the Xcode project. Both Manage Code and Objective-C have support for runtime exceptions, your typical try, catch, and finally clauses. However, the enablement of unwinding the stack is interesting in terms of the implementation and requires special consideration. In the application binary interface, C++ exceptions are supported by the cooperation of 3 layers. The first layer is the compiler. The compiler translates your try, catch, throw statements into calls to specific functions in the C++ runtime. The C++ runtime is in this whole scenario our second layer. However, for exception support, this layer is more or less a wrapper around a third layer. And it's in this third layer where all the dirty work is done, the unwind library. So if your library is making use of the GCC exception handling unwind library, i.e. libgcc_en, then you have to explicitly enable this feature. The is C++ option specifies whether or not the native library is a C++ library or includes C++ code. If your native library contains C++ code, you must also pass the CXX flag in your extra arguments, so that Xamarin iOS knows to use the correct compiler. The kind property is fairly intuitive once you see the options. It allows you to indicate which kind of library is used in the binding, either static or framework. Your library may require additional linker flags. Linker flags are flags specifying native libraries required for linking. So basically, if your framework or library that you are binding needs dependencies included, these need to be specified. These specific libraries are set as space-delimited items. So for example, you may have a requirement around libsqlite. We have to specify this explicitly. Or you may have to include libstandard C++, which this example on screen depicts. The guidance around whether your application needs additional flags will depend on the library or the framework documentation. So at this point, you will have to refer to that to make sure what is required. It is possible to ignore the force load flag when deemed safe by setting the smart link check. Prior to the new type registration system in Xamarin iOS, there was no native static reference to Objective-C classes and methods in third-party native libraries. This meant that you couldn't ask the native linker to remove third-party native code that wasn't actually used, because everything would then be removed. This is the reason for the force load that every third-party binding had to do. The force load flag is usually not required when the static register is in use at compilation time. Therefore, smart linking is a good option. One challenge faced by developers is that of taking advantage of new features introduced in new versions of an OS, while still supporting older versions of the system. Normally, if an application uses a new feature in a framework, it is unable to run on earlier versions of that framework that does not support that feature. Such applications would either fail to launch or crash when an attempt to use that feature was made. Apple has solved this problem by adding support for weakly linked symbols. When a symbol in a framework is defined as weakly linked, the symbol does not have to be present at runtime for a process to continue running. The static linker identifies a weakly linked symbol as such in any code module that references that symbol. The dynamic linker uses this same information at runtime to determine whether a process can continue. If a weakly linked symbol is not present in the framework, the code module can continue to run as long as it does not reference the symbol. However, if the symbol is present, the code can use it as per normal. These frameworks are specified using a space-delimited string. If you are updating your own frameworks, you should consider making your new symbols weakly linked. Doing so can make it easier for clients of your framework to support it. And you should also make sure that your own code checks for the existence of weakly linked symbols before using them. Up to this point, we really have the bare bones in our binding project. We still also have to add the static library of the Facebook library. So let's do this next. Right, we're back in our IDE. We have our API definition file in place. We have our structs.cs file in place. Now we need to add the native reference. I'm going to click on Add Native Reference. Now I've already pre-browsed to the location of the libpop.a file. Remember, it's part of the release-os folder that was created. In include, we have our pop and header files. Here we're going to select that pop.a file. Open this up and add it in. And once it's in native references, you'll see that we are going to be able to set the properties on this file. We've stepped through all of these properties, browsing the slides, and there are a couple of interesting items in here. We are able to choose force load, frameworks, any of these options. What I'm interested in at this point is I want to know which frameworks this library requires. Now, this is something that you will now need to go and have a look at in Xcode. So we'll need to switch gears and we'll need to quickly switch to Xcode to see what is required. Here we have that pop library opened up in Xcode. Now there's a couple of things here that you'll notice. There's my pop.h header file. Here is, if I scroll down, information about this project. Now there's a lot of things here that we can ignore, but what is important is this frameworks section. It will indicate which frameworks are required. You'll see there's actually quite a couple of requirements. For instance, core graphics, core image, Quartz, core, and foundation. Each of these potentially will need to be specified in your CS project. If in doubt, look at documentation, look at code files, and from there work forward. Back in our CS project, you'll notice though that there is still quite a bit of work to do. We figured out that we have to add in our library. We now understand there may be frameworks involved, but we still have a couple of compilation errors, some of them trivial to fix, but others that will require us to understand more about this process. Let's do that next. Let's look at how we verify all of our code, what these verify attributes actually mean, so that we can compile this project. The first compilation of a binding project generally will fail, as we've just seen. The question is, how do we fix these errors? In this next section, we're going to look at what kind of errors we'll run into and what the potential fix for these will be. To understand what needs to be done, you need to understand how the definition files are used to produce compiled binaries. This will give you a good idea in terms of how the various attributes are used in the definition files to clean up the binding. Objective-Sharpie creates the API definition file by interpreting the umbrella header file and all or some of the included or import headers specified. It is typically required that you will verify the API file and clean up potential issues raised within this at compile time. Objective-Sharpie will do its best to interpret the metadata in the original C or Objective-C declarations. It is possible that Objective-Sharpie does not have enough metadata to do so. In these instances, Objective-Sharpie will emit a verify attribute to alert you to clean up or expand the API definition. The verify attribute intentionally causes a C# compilation error, so you are forced to verify this binding. Verification is recommended for all bound declarations, but it's most likely required for declarations annotated with the verify attribute. Objective-Sharpie is going to annotate the verify attribute with a hint of what needs to be confirmed. We're going to step through these options that are available to you, so as to make sure that you understand what is required when you see these in your code. Objective-Sharpie will infer the name of an anonymous type from the common prefix of its members. What this means is, if you look at that verify attribute, the parameter says inferred from member prefix. CF socket callback type is specified in an anonymous enum in the CF socket h header file. Our example here shows how that information is now translated into an enum that is verified and also specifies the purpose of this enum as flags. Methods may be bound as properties to service a cleaner API. Here you can see an Objective-C method was bound as a C# property due to the conventions such as taking no parameters and returning a value, which means a non-void return. Often methods like these should be bound as properties to service, like I said, a clean API, but sometimes false positives can occur and the binding should actually be a method. When you see verify method property name, generally speaking, that's going to give you the hint in terms of what needs to be done. And once you've verified that this property is proper, you can just delete the verify attribute itself. Objective-Sharpie requires you to create class associations for defined constants. Now, to understand why this is required, we need to understand what happens with Objective-C. There is no foolproof way to determine with which Objective-C interface an extern variable declaration may be associated, and typically your constants are extern. Remember, extern is used to tell the compiler that an object of type is declared somewhere. The compiler does not need to know where the type exists, only the name and the type of the object. Instances of these are now bound as field properties in a partial interface into a nearby concrete interface, and this allows us to produce a more intuitive API. Possibly, in doing so, we'll eliminate the constants interface altogether. So here's an example. kseg match limit 1 and kseg match limit all is used to specify the number of search results that's returned from a dictionary. The resulting implementation after cleanup will resolve into the following. So instead of having multiple constant interfaces or multiple fields within constants that might not be related, you can now create a related interface and group your implementation around that. Objective-Sharpie uses generic types where it cannot infer the actual type. What this means is a native NS array was bound as an NS object array. It might be possible to more strongly type the array in the binding based on expectations set through API documentation. And generally speaking, Objective-Sharpie is going to highlight this. So for example, an NS array containing only NS number instances can be bound as an NS number array instead of an NS object. So for example, here we have a definition where question responses is returning an NS object array. Following closer examination of the API and confirming the definition truly exists, you can now return SM question response array from this property. Again, cleaning up the usage of the API so that it is a better experience for your consumer. The key fact here though is that you'll have to know your API. You'll have to inspect and know your Objective-C to understand how to relate this back to a clean API implementation. In general, p-invoke bindings are not as correct or complete as Objective-C bindings. P-invoke statements must be verified or removed. Here's an example of a p-invoke attribute verification. Our cleanup is pretty trivial. As you can see, it's merely just removing the verify attribute. However, there's a couple of considerations which you may need to consider. You may need to fix up the library name and return types manually to conform to the C# calling conventions for your target platform. Or you may find that you don't even want to expose the C API in your binding. If you do, you probably also want to relocate the definition to a more appropriate class and expose a stronger type-safe wrapper. So all of these are things that you will need to think about. What it boils down to, as with the previous slide, is that you will need to know your API, what is used, and how are you going to use it. If you are looking for more information about p-invoke and how to use it in Mono, I would recommend having a look at the link which we provide at the bottom of this slide. The last scenario I would like to discuss surrounding the verification process is constructors. A common pattern from Apple starting with iOS 8 is missing default constructors. The Xamarin binding tool always generates a default constructor and needs to be explicitly told not to emit a constructor where it is required. You go about this by adding the disable default constructor attribute to your API definition. This is going to make sure that the constructor is not emitted. If a constructor is left in your API definition, the consumer of your code will be faced with an exception. Examples of this can be seen in HealthKit and HomeKit, where classes without default constructors are available. The key takeaway from this aspect is again that you will have to know how your API functions to make sure that you can implement a proper binding. Another scenario is where you may have more than one initializer or constructor to choose from. You are now able to indicate which of these should be used as the default constructor. We do this by making use of the designated initializer attribute. Again, you need to know your API to implement the proper implementation. We've covered a lot of ground in today's class. I would like us now to start our last exercise for today and build and bind a library that is completely functional. We'll start off by running Objective-Sharpie, importing our API definitions, cleaning up the API definitions, including our static library, and then finally adding an iOS project that can consume this project from end to end. Your first step with this exercise is to head into the assets folder for the project and do a quick directory listing. We are going to work with the weathergadget.framework file that we see here. Now, in effect, this framework is actually a folder, so you'll see it's a directory, and we'll be able to inspect the contents. So if we change into it, you'll notice that if we do a listing, there's two items that is important to us today. That is this headers directory and this weather gadget file. That's our binary. That's our static library that we are going to bind. To prove this, I'll run lipo info on the file, and you'll see that we'll get resolving information from that. The next step is to inspect what is inside the headers folder. So if I do a quick listing in there, you'll see there are two files, weather and weather gadget. The question now is, which of these two will be my umbrella header file? Now, if you think back, normally the framework name will reflect in the umbrella header file name. So we're going to assume that's that weather gadget H file that we'll use. Our next step is to specify this Sharpie command, but I don't want to run it in this weather gadget.framework folder. I'm actually going to traverse one step back. Here I'll specify Sharpie bind. Next I'll specify the output folder. Now the output folder is where the actual API definition files will be generated. So I'll do something like this. Weather gadget out. Next, I want to specify the namespace to be used inside my project. So again, I'll use the weather gadget, and I think I'll call this weather gadget SDK. Then I have to specify the actual SDK I'm binding against. So this is going to have to be something that is installed on my machine. At this point, I'm pretty sure that I have the iPhone OS 11.4 available, so I'll choose that. The next step is to specify scope. Since Objective-Sharpie will try and bind the world, we need to lock this down to the actual headers folder that we want to observe. So in this case, it's going to be scope, weather gadget, and headers. Next, we have to specify the actual header file. So in this case, weather gadget framework, headers, and then weather gadget. Okay, now let's see what happens when we press enter. Parsing one file, generating an API definition.cs file, and then binding analysis. But you may stop me and say, Chris, but where's the structs and enum file? Not all projects will generate them. If there aren't any structs or enums defined, there's nothing to generate. That's what the case is here. With this in place, we're now ready to jump into our IDE, create a project, and import these files. So let's do that next. Our first step, as always, is to create a new project file. Now, you can either select the previous bindings library if you have that selected in a previous project, or, as always, go to the iOS options in this new project dialog, select library, choose bindings library, then click next. I'm going to generate this project again on my desktop. So let's quickly switch gears and do that. And at this point, I'm going to call it Weather Gadget SDK to match my namespace that I set up earlier when I ran the Objective-Sharpie command. Let's click create. And here's the project available to us. The first step is to introduce the API definition and the structs.cs files into the project. And I think I'm going to do it by deleting these two files, the API definition and the structs file, because you know what, we don't have a structs and enum file to use. So I'll remove both of those two files and permanently delete them. Next, I'm going to right click, add files, and I should be able to get to that API definitions file that was created earlier on. I'll open this and copy it into this files directory. The very first thing I'll need to do is I'll need to set the properties though on this file. So it's not a build action that's set to compile, but it's actually the Objective-C binding API definition MS build action that needs to be set. Right, so once that's in place, obviously we'll be able to do a quick compilation. And since we do have one or two things to look at, we're going to have to update that namespace, and potentially, if I remember correctly, we also had a verify that we have to look at. Good. The next step is to make sure that we add in our native reference. Adding this native reference is pretty straightforward. We'll right click, add native reference, and then we'll traverse back one and get into the weather framework and select weather gadget. I'll bring that into my project, and if I open that up, you'll see there it's selected, and I could set any number of these properties if I choose. Now, there's no external frameworks required. I don't use exception handling in this project. There's no C++ code. Don't need to specify linker code or smart linking or weak frameworks. It's very straightforward. This won't be the case in normal bindings. We want this binding to be as smooth as possible in terms of getting it up and running. There is a couple of interesting things though inside this binding. If we look at this interface document, you'll see that we do have delegates. Right, we have actually two of those. We have a protocol model, so we have a weather delegate, so this is a protocol. And then we have a class. Now, while scrolling down in this, there is something we do have to clean up. We have to verify that this implementation here is actually proper, but it's two things in one. I want you to notice here, we are going to verify that we have a method that is now turned into a property, so fetch historic weather. And what's interesting is we need to confirm this. We need to make sure that our Xcode project actually gives us enough information to answer the question. Because another question that I have is this NS mutable array. We should be able to return a C# version here. So a C# array. Maybe this is weather objects that needs to be returned in an array. Let's go and see what is in Xcode. Here is our Xcode project. Now, as you'll notice, weathergadget.m, that's our implementation file for the weathergadget.h file. Here's our fetch weather historic or a fetch historic weather method, and it is returning an init mutable array which contains weather objects. So we should be safe in terms of returning an array of weather items ourselves. This means that in terms of our verify attribute, we can safely, since there is no parameters passed, it's not a void method, and there are no parameters passed into it, we should be able to return this as a simple property. And you know what? We could even change this to weather objects and an array of those. If you want to test this first, you're welcome to do so, and you can leave this as an NS mutable array. It's your choice. Normally, we want to give whoever consumes our API a C# experience, so I would suggest turning that into a weather array. Right, let's rebuild our gadget and see what's happening here. Excellent, so we have a compilation. Everything seems okay. And what is interesting is the files generated at this point. I want to do the following. I'm going to reveal in Finder my solution. I'm going to have a look at this object folder, and if I open this up, look at what's happened here in the background. Notice that we have in this our SDK implementation. Right, so if I go to this iOS folder, you'll see there's a weather gadget SDK, and then we have a weather.g.cs file, a weathergadget.g.cs file, as well as a weathergadget.delegate.g.cs file. So let's open up these three files and see what are contained in them. Let's see, we'll open them up quickly with Sublime. And let's step through this. Here's my weather file. Now, if you think back to IOS450, there's a couple of things here that might be familiar. Notice there's my weather class. It's deriving from NS object. There's the registration for this class. We are specifying that this is a wrapper class. Here's our pointer to our weather object. What else? Here's the default constructor. Here's how we get to our object itself. There's a couple of things here that's in addition to what you might be familiar. If this is a direct binding, you'll see that we are going to make a choice. Decide how we're going to bind and what we're going to expose. But in general sense, everything is in here that we've learned about in iOS 450. So knowing how to bind something by hand is really important. It makes reading this file so much easier and understanding what is happening. Because at some point you may find that you will have to modify how delegates get generated. So if I scroll down here, we haven't really touched on delegates yet, but you'll see there's a couple of interesting things in here. There's all my protocol members that's been defined. And we'll talk more about this in the IOS452 class. We'll see how to implement protocols and base classes and so forth. Here's the weather gadget itself. You can see the same as before. There's my registration. There's the weather gadget class itself, derives from NS object, pointed to the actual underlying object. Here's my constructor. and various other items that might be in here that I may need to use. Let's go back to the IDE and consume this library. That's the ultimate test. Let's see if we can actually use this library and make sure it's fully functional. In terms of consuming this SDK, I'm going to add a new project, and it'll be a straight single view application, nothing fancy about it. And I'm going to call it weather application, or just weather app should do as well. Click on next, add the project, and then we can clean up the IDE once this project's in place. I'm going to collapse the properties panel, close down application delegate, as well as the API definition file. Next, I'm going to reference the SDK in the projects tab. Now I should have a reference to all the objects that I require. My first step is to do something very simple. I'm going to instantiate a weather object, right? So that weather class that we saw should give me access to something pretty straightforward. I wanted to recreate what we did in IOS450, where we bound the weather class, we're able to set the current temperature. Right, so we'll do something exactly the same. So this is going to be a new weather object, and once we have that in place, I'll make sure that we have the proper using statement included at the top of this code file. With this weather object, I'm going to set the current temperature equal to 99 degrees, and then, just to make sure that everything's in place, I'll execute a quick debug write line statement, and we are going to return the value that's set on that property. So my code should look something like this. Let's see. Let's say temp equals whatever is now stored in weather current temperature. Let's resolve that using as well. I'm going to execute this, throw it into a simulator, and let's see what happens. Right, so there's our file deploying, and what we should see is in our application output, temp equals 99. This looks like a very simple example, and it is, I admit, but it does prove that our project is working, our binding is working as well. This value is set to an object that comes from the other side of the world. So it's from a framework object instantiate, from a native library. We're just binding it in this wrapper class. Let me show you something else. If we were to implement our delegate, remember, we also have this object, our actual weather gadget. This weather gadget has a delegate property. Remember, we should be able to set up a delegate. That was part of what we saw earlier on. So I should be able to instantiate a version of this. Let's go wgadget. Let's instantiate a new weather gadget class. I should be able to now get access to this wgadget, and it has a delegate property. Now this delegate property is going to be something that is based on, let's see, what's our interface here? Weather gadget delegate. So we should be able to set up a new, let's call it my weather delegate, something like this, and generate this class. Now let's see, shall we do this in a nested class? That should be fine. Here's the weather gadget delegate. We'll be able to implement its required member. Right, so let's fix that. Implement this abstract class. Now, I don't need the constructor, so I'm going to get rid of that. That's actually redundant. So we can remove that. Next, we have to implement this method. So what's going to happen? I'm going to ask from the weather gadget a temperature, and then this is going to basically function as a callback. This callback can either fail, so this NS error might be set, but hopefully it doesn't, and this gets returned as null, and we'll see some value in this weather class. So let's see if we can implement this. I am going to make sure that there is no error returned. So with error should return null, and if that's the case, then I should be able to implement a simple debug statement. Again, we'll use write line, and in here we should be able to specify that the temp from the delegate equals weather object current temperature. Okay, so that should be sufficient. Then inside my view.load, I'm going to request a weather fetch. So I can go weather. Let's see, fetch weather. That's my method call. And then this is going to be returned. Let's see if that's the case. I should see temperature specified. That's the object itself. And then the delegate kicking in. All right, so you can see temperature is 99. And then my delegate is going to return a -20. So that's something that's actually set in the class. I didn't specify that. That's hard-coded. That comes from the actual library that we have. As you can imagine, there's a lot more to this story than just this code. For instance, how do I turn this delegate into an async and await method? How do I change some of these into event structures? All of those questions we'll answer in IOS452, our follow-on class. So keep an eye out for that one. We'll touch on that soon. I'm pretty sure you will agree with me that binding the weather SDK was not that difficult. However, there will be scenarios where your binding experience will be more complex. Here's a challenge. See if you can complete the Facebook pop library binding. If you are able to do so, that will be excellent. If you get stuck, feel free to reach out via email or reaching out on the forums. I'll make sure to keep my eyes open for any questions that may pop up there. Thank you very much for your time. In iOS 452, we're going to pick up and carry on this topic. But hopefully, with this information and what we've seen in iOS 450, you have now a much better idea in terms of what bindings entail and how to get to a point where you actually can consume this and use Objective Sharpie to speed up the whole process. So until next time, take care and bye-bye from my side.